Translate and reflect trig graphs. So there are, obviously, like I said, there was no notes video, but we do have notes that we're going to go through for this stuff and then walk through several examples of actually graphing these so that you're prepared for pre-cal. So, translation of sine and cosine graphs. So I mentioned it briefly yesterday, but we have the general form is y equals a sine of b times x minus c plus d. I'm going to use those because that's what my notes are in. I don't know what your book uses. It doesn't matter what letters you put there as long as you know what they mean. Or for cosine, y equals a cosine of b times x minus c plus d. And this is assuming that a is greater than 0 and b is greater than 0 for both of those. So C is a horizontal shift left and right. And these move opposite the direction of the sign. So if it is positive, it goes left. If it's negative, it goes right. So in the general form, the minus c is telling me that I'm going to the right. Then D is the vertical shift up and down. And this goes the same direction as the sign. So if it is positive, it's going up. If it's negative, it's going down. So in our general form, the plus D would tell me that I'm going up.
So when we're putting it in, if the C that we're given is negative, you would do x plus C in your equation?
Well, it's going to be given to you like this.
Okay, so C is always going to be?
Well, it's like they're going to already have given you this. Yes, in pre-cal, you may be given information and you have to write the equation, in which case, then yes. But typically, they're not just going to say C is equal to this. They're typically going to tell you, like, that the graph, like, they're either going to show you a graph and you have to write the equation, or you're going to be looking at it and saying, okay, based on what I'm given, this graph was shifted, like, left, so I know that I need to make it positive, or whatever. All right, now obviously all of that was assuming that A and B were greater than 0, but we know that sometimes that's not the case. So if A is less than 0, it is reflected. So basically that would look like y equals negative A, for example, times the cosine of b times x minus c plus d.
I thought we just said that A had to be greater than 0 for the equation to work.
Not for it to work for this situation.
Okay.
if A is less than 0, then it is reflected. So that's, yeah, we just hadn't accounted for that part yet.
It's reflected across the x-axis.
Yeah,
Okay.
it'd be flipped upside down. There are other things where, like, you can have, like, the negative in here, but typically we don't deal with that. I have not seen one in pre-cal that does that either, so I just don't even worry about that scenario. All right, so I'm going to walk through the steps, which this first couple will be repetitive from what we did yesterday, and then a couple of them will be kind of new. So steps. To graph sine and cosine. And I actually got these out of the AP pre-cal like prep book thing, because I feel like they do a really good job of explaining like how to do this, and then that way again you're ready for next year with that. So and this will be using like the general form that we wrote at the top, so I'm not going to rewrite it, but just know that it would be using one of those original forms. Like I said yesterday, tangent is something totally different, which we don't really like, we'll talk about tangent, but we don't really do anything with that as far as like shifting it around and all that. So step 1, using the A value, determine the amplitude. And so that's why we said yesterday it's the absolute value of A, because if the graph is reflected, meaning the negative's in front, then I've got to make sure that I only am accounting for the positive value. Amplitude has to be positive. I usually just ignore the negative altogether and just go straight to, like, if it was, say, the negative and the 3, I don't even, like, look at the negative, because in my brain, that doesn't mean negative to me, that means reflected. But however you need to think about it, it's technically the absolute value of A. Step 2, using the B value, find the period, which is 1 full cycle. And so the period is 2 pi over, again, technically the absolute value of B. A lot of times they'll just write B because it's very rare that you'll see B being negative. Step 3. So this is where we're getting into the new stuff, since we're actually getting into graphing. To figure out how to scale the x-axis, because I'm going to be honest, in high school this was like the hardest thing, and I wish somebody would have just shown me this formula to find how to scale it instead of me sitting there playing a guessing game the whole time. We divide the period by 4. So it is P divided by 4. So for example, on your parent function, the period was 2 pi, and that would be divided by 4, meaning increments of pi over 2 is where our next point would be on the graph. Step 4, using the C value, shift the appropriate units left or right. So following what we had written above. It's positive, it goes left; negative, it goes right. Step 5, using the D value, shift the appropriate units up or down. Remember, these go the same direction, so up is positive, down is negative. And finally, step 6, determine whether or not the graph is reflected. Now, if the graph is reflected, okay, so this is like the order of like finding everything that you need to be able to graph it. If the graph is reflected, after I graph the parent function, okay, and when I say the parent function, I'm meaning like my initial function. Obviously, they're not all parent functions. So if it's like whatever the graph is, if it's being shifted and all that, I will actually reflect my graph and then I will shift it. Because a lot of times if you wait and reflect it last, if it's been shifted, you get confused about, okay, well, where is this actually supposed to be? And I find more mistakes in people's graphing if they wait and reflect at the end. But as far as like going through, like when I'm given a problem, I'm going to write out all of these things. I'm going to say, okay, my graph's going to move left pi. It's going to move down 2. It's going to be reflected. And then I'm going to go through and do those things. You can do them step by step. Or you can do it in like chunks and do like certain things at a time. So I do it kind of different ways depending. So as I'm showing the first one or the first couple, I'll show like every little thing. But after that, then I'll probably like kind of do like the left and down shift at the same time. So we'll talk about that and how that works too. So starting out with an example here. F of x equals 3 sine of 2x. And I'm going to like legitimately work through step by step. So step 1 is to find the amplitude. So what is the amplitude of this graph?
3. Absolute value of 3.
So ultimately it will just be 3, yes. Step 2, I want to find the period. What's the formula for period?
2 pi over
2 pi over b, so in this case, what would that be?
2 pi over 2.
2 pi over 2. Oh, I guess I should actually write period first. So 2 pi over 2, which is just pi. And the next thing is my scale. And I usually write x scale when I do this so that I don't get confused. I've had some people try to scale the y-axis before, and I'm like, not sure why you're doing that. But anyways, so that's the period over 4, so that'll just be pi over 4.
So, yeah.
When the period is a fraction, obviously, then that's another whole like
So
thing
when you're
for
saying
scaling.
x scale, you're saying that 1 unit on the x-axis is pi over 4. Is that what the x scale means?
Yeah, so like how we would normally like on the x have like 1, 2, 3, 4, it would be like pi over 4, pi over 2, 3 pi over 4, pi. So like in your parent function, you had like when you graphed it, we had the 4 things. You had 2 pi and pi. You had pi over 2, and then this one was 3 pi over 2.
Yeah.
So this one was scaled by pi over 2. So this one will be scaled by pi over 4.
Okay, that makes sense.
All right, was this one shifted left or right?
This one, yeah.
It is shifted left since it's positive.
There's no parentheses, so no shift left or right. And I'm going to also say I would not normally write this, okay? I'm only doing it right now so that we're looking, while we're like looking at it. But as we go, like if the next one doesn't have a shift left or right, I just skip step 4 altogether. So if it doesn't have something, we just skip it. Step 5, does this one shift up or down?
Neither.
Correct. There's nothing being added or subtracted at the end, so there's no shift up or down. Again, I wouldn't write that if we weren't doing it like step by step. Step 6, is it reflected?
No.
No. So this one is not reflected. So I'm going to set up a graph over here. So when the amplitude is like 3 or whatever, if I know it's not getting shifted, a lot of times, like, I just will go to like 3. If it is getting shifted, obviously we've got to put more markings on there. But I'll usually just mark off like 3 and -3 as far as that goes. So my x scale is pi over 4. Anytime we're graphing a trig function, we have to graph one full cycle. So I've got to have 4 spots here. So the first one is pi over 4. Then I've got 2 pi over 4, which reduces to pi over 2. Then I've got 3 pi over 4. Then I've got 4 pi over 4, which reduces to pi. On the x-axis, you need to write what you are scaling by. Okay? Like, you need to write out all of them. On the y, since it's just increments of like 1, or sometimes you may do 2 if the number is really big, like the amplitude's big, then you don't necessarily need to write all of them. But as far as the x-axis, you do need to write them. And if I know it's being shifted, again, I'm going to put some on the left side. I'm going to add some more on the right side, depending on which direction it shifted. Not that I can't do it on this one. I absolutely could, but since it's not being shifted, I'm not going to. So I'm ready to graph now. Where does sine start?
3. Sine starts at -2 pi. Or at the middle thingy. The domain. I mean the origin.
It starts on the origin.
At 0, yes, at the origin. Sine always starts here, and then we go up. So at 3, so at pi over 4 and 3, we have a point. At pi over 2, 0, we have a point. And again, we could plug these numbers in and we could check to see what's happening. And then down here at 3 pi over 4, goes down and then back. So it's always going to follow this. We don't ever just start our graph here, okay? I don't ever just start there. It always starts below because this graph goes on forever, okay? And it's rounded off. It's not pointed. It's not a mountain that's like just like peaking. They're not absolute values. They're rounded. Okay, and we always draw the arrows that they keep going. If you stop at those points, I will take points off because the graph doesn't just stop. So that's all that's happening to this one. Since there was no shifts, no reflections, I'm done. These should be the easy ones, because nothing's happening to them. Any questions on that one?
So why do we go up 3 and pi when it's pi over 4? Is that just how it is always?
It always starts at 0 and goes up.
Only,
And then
it
down.
only goes up 3, or is it just because
It's
that's
the
what-
amplitude. It goes up to your amplitude.
Oh, so these are like frequency waves. And then, okay, that makes more sense.
Yeah. All right. Let's see. G of x equals -2 cosine of 1/2 x. All right, so again, if something's not happening on this one, I'm probably just going to skip it because it just takes too much time to write it. So step 1,
Amplitude.
what is the amplitude?
2.
Yep, so it would be the absolute value of -2, which would just be 2. So I usually just write a equals 2. If you need to do the absolute value thing, you absolutely can. All right, step 2, what do I do now?
P equals 2 pi over 1/2.
P equals 2 pi over 1/2. What happens then, or what is it equal
4
to?
pi.
4 pi, keep, change, flip. So then scaling, this one should be nice and easy.
4 pi over 4.
So 4 pi over 4, which is pi. So that means that my x-axis is being counted as pi, 2 pi, 3 pi, 4 pi. Okay, that gets me out one full cycle. Is this one being shifted left, right, or up, down?
No.
Nope. Nothing's being added or subtracted there at the end. Is it reflected?
Yes.
Okay,
Step 6.
so it is reflected. So the very first thing I'm going to do when I graph this one, I'm actually going to have two graphs. Okay, so if you want to use colors when you do this, you can. It's okay if you don't, but you've got to make sure you show me which one is your final graph. Okay.
Green,
Green,
darker white.
black, green, black, green.
All right, so I'm going to set up my graph here. I've got an amplitude of 2. And then I'm counting increments of pi. So pi, 2 pi, 3 pi, 4 pi. So the very first thing I will always do is I'm going to say the parent graph, but I'm just going to say the graph with nothing happening to it. Okay, no shifts, no reflections. So, where does the cosine graph start?
Cosine starts.
At your amplitude.
Okay, yep, at the amplitude. So it starts up here and it goes down. So at pi it's 0, at 2 pi it's -2, at 3 pi it's 0, and at 4 pi we're at 2. So when you do this graph, again, it doesn't keep going up, so I'm going to round it off, okay? This should look like a V when you graph this. And so it loops back down, because the next thing that would happen if I continued my graph, which I'm not requiring you to do, is that it would be going down at both ends. Okay? I've got to draw those arrows showing that that's what's happening.
So it's a.
Now, this is my initial graph. Okay? So then in red, I'm going to do my final graph. So reflected means that everything is flipped over the x-axis. So this point that was at +2 is at -2. The point that's at 0, obviously that's not going anywhere. That point happens to stay. This point that was down here at -2 is now at +2. This point that was at 0 stays there. This point that was at +2 is now at -2. Now, what we do is, instead of it going down first, it's going up. So, I come in here, and I connect.
Whoa. It's like
Now, if you're using pencil for everything and you're not switching colors, then what you need to do is you need to come over here and you need to point to which one is your final. I'm not going to sit there and try to guess which one you think is the final, because some people think that the graph that I just did as the reflected is what the initial looks like. So I'm not going to sit there and try to guess.
That's sure.
Now, if there's shifting and all of that going on, obviously you don't have to change colors every time. I mean, you can if you want to. That's fine. And obviously, be very careful if you are using like ink pens or something, because if you make a mistake, then you pretty much got to start over, because you can't just like scratch it out in the middle of a graph. So,
Okay. This is easy.
I don't want to do the hard ones.
well, we're getting ready to get into a harder one. All right, h of x equals 3 cosine of x plus pi plus 1.
Example. Give me 1 second to copy.
No problem. Well, I'll wait for Zach.
Hey, I think there might not be an amplitude. I don't know. There is an amplitude. It's always the one before the sine and cosine. It's the absolute value is all the way on the left.
You're talking about the b value.
Yeah. Wait, Shepard, write your steps
Even
out.
still, there's a b value in this.
Oh, it's 1.
All right, what is the amplitude here?
1.
3.
3. Amplitude is in front of sine or cosine. Amplitude's always out front.
So
A always comes first.
Okay, so amplitude is B, right?
No.
Amplitude is A.
Oh.
A always comes first.
That makes sense.
Amplitude
I
A.
was thinking
Amplitude
about-
starts with A.
Shepherd, I told you. I said it's
The one after.
I said it's the
cosine
concept
sine
at
is
the
B.
very
Alright,
left.
what about the period?
Wait, it's P.
2 pi over 1, which is just 2 pi. Okay, because B is 1. There's a 1 there.
2 pi over 1, which equals 2 pi.
Wait,
Step
that is-
3.
2 pi over 4. Because it's the period.
We're going.
Yep, 2 pi divided by 4. We always take the period and divide it by 4, so that's going to be pi over 2. So that means this one is scaled just like our parent function graphs are.
Pi over 2. It is.
I just heard Shepard say it shifted left pi, and yes, that is true. So it goes left pi. What else is happening?
Up 1.
Up 1. And is it reflected? No. All right, so I'm going to have my initial graph, okay, which is just the first 3 things, the first 3 steps. Then I'm going to shift it left. Then I'm going to shift it up. Sometimes as you get more comfortable, like what I usually do is I will do the left and up at the same time, okay? You can do that. I would not recommend that initially, but we will get to that eventually.
No, 3 different colors.
Yes.
So we're drawing 3 graphs.
Yeah. I'm just.
Shoot, I don't have enough room on my paper.
Can we just do 3
What's
different
on the
colors?
same graph?
It's on the same graph. You're supposed
Well,
to
yes,
draw
it's on one
I
graph.
just erased my graph.
Did you not pay attention to the last one?
No, I did, but then Ron was like, "Do we have to draw 3 graphs?" I said, "Yes, draw 3 graphs." You
Well,
made
it
fun
is
of my
3.
graph, but you didn't draw
All right,
I didn't
so-
say anything about your graph.
The amplitude is 3, but I also know it's getting shifted up 1, so I'm going to also put on the y-axis, I'm going to go all the way up to 4 because I know it's going up 1.
4 squared, 7 is
Now on the negative y, I'm still going to just go to 3. If you like your graph to be symmetric, you can put the 4 on the bottom also. Now, on the x-axis, on the right-hand side, I'm doing increments of pi over 2. I have to have the 4 for the initial. So pi over 2, pi, 3 pi over 2, and 2 pi. If you want to know how I used to do it before I was taught this formula for scaling the axis, they used to just tell us to find the period, cut it in half. Cut that in half again, and then basically play a guessing game till you figure out what this one over here was. And that got really annoying. I really wish that somebody had just told me this formula
That's stupid.
in high school.
Why would they do
Anyways,
that to you?
I don't know. All right, now, but I know that my graph is going left pi. As far as my scaling goes, what does that mean is happening?
We go 2 notches to the left.
Yeah, it's going 2 places to the left, so I need to go all the way to negative pi on the left-hand side. If you want to go farther than that, you can. So negative pi over 2.
That's a lot.
That's a lot of numbers.
All right, so the first thing I'm going to do is simply graph it as it sits if it does not get shifted. So that's going to be my initial.
And it starts at amplitude 3.
Starts at the amplitude of 3 because it's cosine. We go down, down again, up again,
Shoot.
and then I connect. I think you just went down too many times.
Oops.
He's good.
All right, so the blue is my initial graph. Now, I'm going to do, it doesn't matter if you go up first or left first. That's why I said a lot of times I do it at the same time. But I'm going to do the left pi just to do the steps in order. So everything is going left 2 spots, right? Because it's got to go pi. So this one's going from 0 to negative pi. So it's going over here. This point is going from pi over 2 to negative pi over 2. This one's going from pi to 0,
So it keeps waiting.
3 pi over 2 to pi over 2, and 2 pi to pi. And so,
This is not the final, correct?
correct.
Okay.
Frick.
So this green one is my, actually, I'll just do this over here, is my left shift by pi.
Oh, wow, like this.
It's
Oh, I
Now
already
my
messed up
last
that.
thing I'm going to do in red is every point's going up 1. So I just take the point and I just take it up 1 spot. So this one going up here, here,
oh, it's so pretty.
here, 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 and then
Okay, our final.
connect it. So my final is the red. So again, if you're doing it in all pencil, then you need to make sure you clearly label which one is your final.
So the final is just your initial. No. The final is
the
just.
final graph.
The final is just the green up one.
Yes.
Okay. And what is the green one called?
I thought the red one.
I just will, when I'm doing the shifts, I'll just put what color it is next to what shift I'm doing. Now, if you got to where we were doing, like if you did the left and the up at the same time, then what I'll usually do is I'll just come over here and I'll do something like that, showing that I'm doing it in both things.
I hate writing in pen. I messed up my graph 3 times.
I always do it.
Now there's a bunch of green dots all over my graph, and I don't know.
I honestly think sine looks cooler than cosine. I mean, I know they're the same.
It looks like the water.
But I'm talking about
burger.
just in isolation. I think sine looks better than cosine does.
Mine looks like the water burger.
It's more satisfying, I think.
Signal. Stop. But it's just missing another double. I actually took good notes. Like, I never take this good of notes. Yeah, what are my notes? Yeah,
Right?
like,
Where are we at time-wise? All right.
Wow.
I'm very confident in my
Looks like
ability
I'm not
in this section.
Oh, it's like
See, mine's better.
yeah.
Wait, why exactly are you Yeah, what happened?
I like how you like.
Depends on the class.
Look at
It's
my
really not.
notes. Look at my notes, Julie.
They're amazing. I can actually read them
These are
because they
my
kind of
notes.
look like my handwriting.
All right, one other thing I want to point out about this problem, I don't remember if it happens in the Algebra 2 book or if it's in the pre-cal book that it happens, but I know I stumped pre-cal with it on a quiz the other day or test. This problem could also be written as 1 plus 3 cosine of x plus pi. Okay? The number directly touching the trig function is your amplitude. The amount of people that I had on that test tell me that the amplitude was 1 was mind-blowing.
Wow.
Okay? Because I had this very conversation with them. So, it's always the value that's directly touching. If you're ever given a problem this way, I would move it, okay, like this to make it in the correct standard form of the graph. Does that make sense?
Mhm.
Because the amount of people that get it wrong, okay, is amazing.
I don't
The other thing about it is if the value is not in parentheses, okay, and it just said, in this case, if it was 3 cosine of x plus pi, no parentheses, okay, that pi would tell you it's going up pi. Now, typically your amplitude is something like 3 or, 2 or whatever. Obviously, if we're going up pi, that's kind of difficult. Y'all are going to be real confused if you're over there giggling and throwing around a tortilla or whatever that is.
Sorry.
Okay? If it ever is going up by pi, okay, what is pi approximately equal to?
3.
Okay? Yes, 3.14. I would just approximate 3. I'm not going to get out a little ruler and measure. Just go up about 3 spots if it goes up that way. Okay? If your graph is ever shifted left by like 3, okay, then approximate that goes over around pi. Okay? Because that's something that they got stuck on. They had one where their I guess it was going like left 3, which is not something that they normally have. It normally is in increments of some sort of pi. And they were really confused, and they pretty much all got the graph wrong because they didn't think 3's around pi. So instead, they just all went like one notch over, which was like pi over 4 in that case. Okay? Pi over 2 would be like 3 divided by 2. Okay? Things like that. So just think about that. Again, doesn't really happen as much in this book, but I'm just giving you a heads up for next year in case you have that, just to be aware. All right. See if we can get in like 1 or 2 more here. Number 12. So these are actually starting in the book now. Y equals sine of 3x minus 4. Now, a lot of times I won't necessarily write step 1, step 2. As I get more comfortable with it, I'll just say the amplitude is what?
Amplitude is 1.
1. What's the period?
Pi over 3. No, 2 pi over 3.
2 pi over 3. This is where you're thankful for the scaling, because having to cut that in half, then cut it in half again, and then figure out what that other one is a royal pain. So, scaling now. 2 pi over 3, all divided by 4, which would be the equivalent of 2 pi over 12, which would be
1 pi over 6.
pi over 6. Okay, so I'm scaling by pi over 6. What else is happening to this graph?
How did you do that? How?
Keep, change, flip.
No, but like
No.
how?
Not keep, change, flip.
Is it because it's a 1/4?
Because this is the same thing as 2 pi over 3 times 1/4.
Is that not
So
keep?
2 pi over 12.
I thought that was keep, change, flip. You
No.
kept the 2
No.
pi over 3. You change it to...
No.
Change would be change.
You're
That's
not
if there's a
flipping
fraction on
anything.
the bottom for dividing by a fraction. I didn't divide by a fraction, I divided by a whole number.
So would that not be 2 pi over 3 times 1 over 4, which is...
That is what
That is
keeping-
what it is.
But you kept 2 pi over 3, you changed it to multiplication, and then you flipped the 4 over 1.
No, she didn't.
No.
If you said
That's dividing by a fraction.
pi over 3
But would that not
divided by
work?
4, then yes.
I never knew you.
Is
could
that not
have
what
a
it says? 2 pi
fraction
over 3 divided by
inside
4?
of a
Yeah, it's not
fraction.
divided by 1/4, it's divided by 4.
So it is
If it was divided by 1/4, I would keep, change, flip. This is just divided by a whole number of 4, which is the same as multiplying by 1 over that number.
I'm confused
So
because
yes,
you-
she did.
it is kept, changed, and flipped in that equation right there.
Since
Right.
when? did we
But
start
that's not what this
dividing
is.
Fractions by fractions.
I took a fraction and I divided by a whole number, which is multiplying
She
by
kept
1
it,
over that number.
And she didn't change or flip it.
So
I didn't divide by a fraction, I divided by a whole number.
you divided by 4 over
Next.
1, so then you had to multiply by 1 over 4. So yes.
Guys,
Miss
What
Quinn's
are we
right.
talking about?
I'm trying to just cut
Alright.
you off.
If he thinks about it that way, he's going to end up getting it wrong. That's why I don't want him to think about it like
Miss
that.
Quinn's right. Next problem.
Okay, what else is happening to this graph?
this is going to be to the
Move
right.
down
Down.
4.
Why down?
There's no
Oh,
parentheses.
Down 4, there's no parentheses.
so it just stays down there.
Alright, so
So it goes
let's see, I'm gonna
the initial
so if I know it's going down 4 and I have an amplitude of 1, that means I need to go down to -5.
Do you still want us to do the initial?
Yes, I'm just setting up my graph.
Oh, okay. That's what I was.
Can't graph it until I have scaling markers on there. Now, increments of pi over 6. So this is 1 pi over 6, 2 pi over 6, which is
Pi over 3.
That makes so much.
3 pi over 6 is
2.
Pi.
pi over 2.
Pi over 2.
4 pi over 6 is
2 pi over 3.
2 pi over 3.
Whoa.
Good,
I
because
never
that was
thought
the
of it
period.
like that.
So, I'm not gonna, never mind.
So you just add pi. Why didn't we go 6 numbers?
Because
we only need 4
Because you only ever use 4.
we're not shifted
Okay,
left
so we
to right.
always only use 4.
Unless it was going right or left.
Okay, so we always only use 4 thingies across.
One full cycle is 4 spots.
Okay.
Well, technically 5 because we have the initial one. But
Okay.
1, 2, 3, 4, 5 is
It's like a
technically how many
circle,
points
right?
go on there. Huh?
It's like a circle.
Yes.
Like we're going like that.
If we get to polar coordinates, I don't think we'll do that in here. If we get to polar coordinates, when we do that next year, it'll make more sense. The graphs that look like flowers and all that. Yeah.
My uncle showed me some.
Yeah. There's graphs that look like flowers and spirals and
Wow.
all kinds of fun stuff.
Can we draw?
No.
No.
Let's finish this.
If I teach it, you get a quiz on it.
Oh.
Oh yeah.
No.
All right. This one had an amplitude of 1. This was sine. So where does it start?
0.
0. Yes, the origin. And it goes up. And then down. Down again. And back up.
I like this graph.
That's the.
I don't like this graph. My dot is inside of my pie.
All right, now every point goes down 4. So
Wait, what did it? Never mind.
my final is everything's going down 4. So 1, 2, 3, 4. Down here. 1, 2, 3, 4. Down here. 1, 2, 3, 4. Down 1, 2, 3, 4. Down 1, 2, 3. Whoa, 4. That's not pretty, but that's okay. I also sent that way too far down, but that's okay. Just gonna roll with it. So this is my final here.
Zach did do this. No, my pen ran out of ink.
Oops, I forgot to label. Oh, it doesn't matter. I can label it.
I'm gonna do it right now, Ryan. Look. Yeah, I just say 4 points.
This is so much easier than the triangles.
All right, we're stopping there for today. We have a couple more we'll do tomorrow, and then y'all will have some to do. There's also a couple where we will be writing the equation, given information where they tell us, like, this graph has been shifted left and so many units, and then up so many units, and you'll actually be writing the equation. But those are actually really easy because, one, you don't have to graph them, and 2, follows the standard form. So we'll probably do like 2, maybe 3 more graphs depending on how y'all are feeling about it, and then y'all have some to do on
This
your
is the
own.
best section in math so far.
Yeah. We don't have time to get to another whole one, so I don't want to just start it.